Brainflow is a library intended to obtain, parse, and analyze EEG, EMG, ECG, and other types of data from biosensors. Brainflow offers a consistent data acquisition API for all supported boards, allowing users to switch boards without modifying code. Brainflow supports Python, C++, Java, C#, Julia, MATLAB, R, TypeScript, and Rust. In this series, I will demonstrate how to build a Rust application that plots real-time recordings from a synthetic board. To begin, we need to download Brainflow and set up the necessary libraries for our application. I have already cloned Brainflow from GitHub to my home directory. Within the Brainflow directory, there is a folder named Rust Package, which contains a subdirectory also named Brainflow, following the typical organization of a Rust package. Here is the tree view of our cloned repository, with the Rust package being our main focus. The Tools folder includes a Python file for building the necessary components for coding in Rust. Now, let's compile Brainflow's core module and C++ binding. Refer to the Brainflow documentation, and click on the provided link. Skip the Windows instructions and proceed to the Linux section. To compile easily, ensure you have Python and CMake installed. If you are unfamiliar with CMake, you can search for more information online. Navigate to the Tools folder mentioned earlier, open a terminal in this directory, and execute the build.py file. After the compilation, we can see new folders at various depth levels. Let's focus on the Rust package directory and create a new Rust project. Now, within the Rust package directory, there are two subfolders. I will use a sample file for demonstration shortly. I will remove unnecessary folders, keeping only the Rust package folder. I move the Rust package folder to my home directory and delete the Brainflow directory. The first task is to update dependencies in the cargo.toml file to their latest versions, which I have already done manually. Within the examples folder, there is a file named get_data.rs. I will copy the code from this file and paste it into the main.rs file. I will then proceed to explain the code line by line. But first, let's compile the code. I forgot to specify the location of Brainflow in the cargo.toml file. We need to update the cargo.toml file to include the path to Brainflow. By indicating the correct location, we can guide the code to locate the dependency. Let's rebuild the code. It worked. However, the compiler complained about the camel case constants, and I don't like the warnings. So I want to change them to uppercase. It's strange that I couldn't find any code using these constants. The sample code is quite short, so I'll analyze it line by line. Here, we can directly use board SHM due to name binding in the use declaration. The logger is not related to real-time plotting, and its purpose is unclear to me since I don't have any experience with EEG boards. This line of code builds input parameters to define a board. I don't have a board, so I use a synthetic one. We then call the prepare session method to allocate resources for streaming and start the streaming process. The input number specifies the buffer size. These lines of code put the current thread to sleep for 5 seconds. Then stop the streaming. Collect and remove the board data from the ring buffer. And stop the session to release all resources. Finally, the results are printed on the screen. In the next video, I will focus on plotting this data. Thank you for watching.